Okay guys, so this is lesson 5-6. It is very similar to lesson 5-5. So just a little bit different. Really the only difference is when you find your solutions and you use the quadratic formula, you're going to end up with some imaginaries. So basically it's just imaginaries. Okay, so let's go ahead and start. I'm just going to go down here. Okay, so in that box right there, basically what that's saying right there, you guys, is if you have an imaginary solution, you're going to have the conjugate pair, the pair that goes with it. So for example, if you have x equals I as a solution, that's like x equals 0 plus I. Well, the conjugate of that is 0 minus I, which is the same thing as negative I. So if you have a positive I, you're going to have a negative I for sure. Say you have 3 plus I as a solution or a 0, then you know you're going to have 3 minus I also as a solution. Okay? Okay, let's go ahead. So find a polynomial with the given zeros. Okay? So this one right here says degree 4 and it lists the zeros. Okay? So you know it's supposed to have an x to the 4th. So this is going to be y equals. You have a solution of 3. Now this says multiplicity 2, which means twice. So if you have an x equals 3 as a solution, you have an x minus 3 as a factor. And the fact that it's multiplicity 2 tells you to square it. Now you have a negative I, which gives you an x plus I. The reason that gives you x plus I is because if you had x equals negative I, the negative I comes over and becomes a positive. But remember, i's come in conjugate pairs. So if you have a negative I, you also have a positive I. So the positive I comes over to the other side and you get x minus I. Make sure you dot those i's very clearly so I can see. And you have exponents of 2, 3, 4, and it's degree 4. Okay, simplify means to multiply it out. Okay, so it looks like it's going to be terrible. It's actually a little bit less terrible than what you'd think. So x minus 3 squared is x minus 3 times x minus 3. Okay, and then you have x plus I times x minus I. Now, these right here are conjugates. So I'm going to multiply those together first. And when you FOIL conjugates, the O and the I cancel out. So all you have to really do is just F and L. So when I'm going to FOIL these as well. So when I FOIL those, I get x to the second. Negative 3x is a negative 6x. And negative 3 times a negative 3 is a positive 9. Now when I F and L those conjugates, it's just x times x is x squared. Positive I times a negative I is a negative I squared. Remember from 1010 or secondary 3 that I squared is really equal to a negative 1. You don't want to leave it as an I squared. So this is minus a negative 1, which really gives you a plus 1. Now I have to take this x squared and distribute it across that whole second parenthesis. So it's going to get a little squishy, and I'm very sorry. So it's going to be x to the 4th. X to the second times 1 is x to the second. Now do the negative 6x. So negative 6x times x squared is a negative 6x to the 3rd. Negative 6x times 1 is a negative 6x. And then 9 times x squared is 9x squared. And then 9 times 1 is 9. And now all you have to do is clean it up. So your answer would be y equals, you have an x to the 4th. And then x to the 3rd, you only have 1. So minus 6x to the 3rd. On the squareds, you've got a 1 and 9. So that gives you a 10x squared. You have a negative 6x and a positive 9, and that's your answer. So that multiplication would have been way more difficult had you not multiplied those conjugates together first. So just make sure you always do that. Okay, this one is degree 0. You have a solution of 2 plus I, which means you also have a solution of 2 minus I. You also have a solution of 3. Okay, So it's going to be y equals, pardon me, negative 3. So the negative 3 solution gives you a factor of x plus 3. Now, this is a little awkward. I don't think you'll probably ever see it, but look at that. So you have a solution of x equals 2 plus I. So all you do is take those guys right there and pull them over. So then the factor would be x minus 2 minus I. Then you also have a solution of x equals 2 minus I. So take those guys and pull them that way. So then you have an x minus 2 plus I. I would never have you multiply something like that out. The directions say do not simplify. That means do not multiply. Okay, so that's it. Okay, so question 2 looks a lot like what we did in 5.5. Okay, now they do tell you right here that you have a solution of 2i. So you know if you have a 2i, you have a negative 2i. Those aren't rational. Remember, rational don't have i's, they don't have square roots, they're just regular numbers. So I can see right now that I know I'm going to have another 0 of 2i and another 0 of negative 2i. Now, to be honest, I never do that. I never do that because I can just figure it out, okay? So here's another thing. If you look at that, x a third minus 3x a second plus 4x minus 2, I can tell that that thing's going to factor. The way I can tell it's going to factor, guys, is this. Look at those numbers 1 and 3. Could I take a 4 and 2 and turn them into a 1 and 3 by pulling something out? Well, if I factored out a 4, I'd be left with x minus 3, and now I've turned it into a 1 and a 3, and it matches, okay? So that's how I test if it factors. So finding the rational zeros, you don't have to do the possibles and all that stuff because this thing factors. So I'm just going to go like this, okay? Now, so I'm not going to do this by grouping. I'm going to do this by guess and check. So see this x to the third? It's going to go to an x to the second and an x to the first. It has to, okay? Now, you want the x to the second to be a negative 3x second. So whatever goes here is going to be multiplied by this x squared. You want it to be a negative 3x squared. So that's going to be a negative 3. You want your x to be a 4x. So what would I put here to make, when I do I on FOIL, 4x? That would be a plus 4. Then I always take a quick second and I look at it, and then I check my L, I check my last terms. So is a positive 4 times a negative 3 a negative 12? Yes. Okay. So this guy gives me a rational 0 of x equals 3. So I've taken care of that one. This one right here, x squared plus 4 equals 0, that's not going to be rational. Now, I have seen Weber State take off points for showing this work right here in part B, because these aren't really rational, so this should really be written down here. So it's x to the second plus 4 equals 0. I can tell they're not going to be rational by looking at it, because look what I'm going to do now. The 4 is going to come over and become a negative. Then I square root both sides, and I get plus or minus. The square root of negative 4 is 2i. Well, I already know those were the solutions. Yes, I do have to show that work still, but it just, verifies that I got it right. So basically that's it. Okay, so let's move on to example 3. You guys, I will tell you this. I've looked through old midterms. I've spent some time doing that over the past few days. And this process of having some imaginary zeros, other zeros, and that kind of thing, it's on almost every single final. So anyway, solve by factoring. So this is simple. So it's just x to the fourth minus 3x to the second minus 28 equals 0. Now, x to the fourth is a little strange, but don't be scared. All you have to do is look right there and know that you split it to an x squared. So it's going to go to an x to the second and x to the second. Two numbers that multiply to give me 28 and subtract to give me 3 are 7 and 4. Okay, the biggest needs to be the negative, so it's going to look like that. So if I set this equal to 0, I get x to the second plus 4 equals 0. If I set that equal to 0, I get x to the second minus 7 equals 0. Solving the one on the left, x to the second equals negative 4, square root it, x equals plus or minus 2i, okay? You can do an or, you can do a comma at the end. This guy right here, the 7 comes over and becomes a positive, square root it, and you get plus or minus the square root of 7. So all of those work. You know, when you take your midterm, you guys, you're going to want to check as many answers as possible. So if you stored the square root of 7 in your calculator using that store button, and then you put it into the original, you should get a 0. Negative square root of 7, store it in, plug it in, you should get 0. So that's a way to check at least those. Okay? All right, example 4, find all the zeros. Now we're really looking like we're back to last time's lesson. Why do we have to do the possibles and the long division? Because that thing doesn't factor, okay? I can tell by looking at it that it doesn't factor. How can I tell by looking at it? Well, look at the front numbers. They're 1 and 8. Can I turn a 25 into and a 26? Can I turn this into a 1 and this into an 8 by factoring something out? No, okay? So possibles are going to be plus or minus. What goes into 26? 1, 2, 13, and 26. Okay, I think that's it. The leading coefficient's a 1. What goes into a 1? Just a 1. I could put a 1 on the bottom, but that doesn't do me any good. And then I'm going to have to rewrite it. So I may as well just keep it the way I had it. 1, 2, 13, and 26. Okay, now this part is just a little bit tedious. So you have to sit and plug those numbers into your calculator. So go 1, store, enter. Then go memvar, enter, raise it to the third. Minus 8, memvar, enter, x squared. Plus 25, memvar, enter. Minus 26, enter. And 1 did not work because I didn't get a 0 when I plugged it in, the number 0. Now do negative 1, store, enter, up, up, enter, and I didn't get one. I'm going to do a 2, 2, store, enter, up, up, enter, and I did get it. Okay, so that was a 2. So I know x equals 2 is going to be a solution. I'm going to make sure I show that clearly. Okay, I have a 3, I have a 2, I have a 1, I have a constant, so I'm good. Coefficients are 1, negative 8, 25, negative 26. Now take the 1 and bring it down. 1 times 2 is 2. Negative 8 and a positive 2 is a negative 6. Negative 6 times 2 is a negative 12. Combine, I get a 13. 13 times 2 is 26, and I don't have a remainder, and that's what should happen. Okay, now this was a third, so this guy's going to be a second. So now I have x to the second minus 6x plus 13 equals 0. That's what I have left. Once I factor those, then I'm going to get the 2 remaining solutions because I have 3 and I've found 1 so far, so I know I have 2 more. Now I said once I factor, but this guy actually won't factor. And remember, Weber-State gets a little picky with this, so I would probably just rewrite it like that. I know it doesn't factor, so I'm going to do quadratic. So I have x equals 6 plus or minus the square root of negative 6 to the second is 36. Minus 4 times a, which is 1, times c, which is a 13, all over 2 times 1 is a 2. People mess up on this all the time, so grab your calculator and put it in. So go 36 minus 4. Obviously, we don't need the 1, so I'm going to go parenthesis 13, close it, and I get a negative 16. So now I have x equals 6 plus or minus the square root of negative 16 all over 2. Now people start getting confused on how to simplify this. I cannot cancel the 6 and the 2 because I have 3 terms. Look, term, 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 and I would be excluding that one. You can't just simplify with 2 terms. You guys, the square root of 16 is a 4i. So I'm going to write it like that. Then 2 goes into 6 and 4 and 2. So now I can reduce as long as I'm involving all 3 of those. So my final answer is 2 goes into 6 3 times, 2 goes into 4 2 times, 2 goes into 2 1 time, so it's 3 plus or minus 2i. So I found 3 zeros. Look, here's 1, and then I've got 3 plus 2i, and then 3 minus 2i, 3 solutions. That makes sense. My biggest exponent's a 3. Okay? Like I said, you're going to see this, period. There's no question that you're going to see this. Sorry. Okay, here we go with question B. Okay, way too long to be able to be factored. Okay, so scroll a little bit more. Sorry. There we go. Okay, so possible zeros are going to be plus or minus, then a parenthesis. What goes into that constant? 1, 2, and 4. What goes into the leading coefficient, which is a 2, 1, and 2. Make sure you don't write it like that. So it's plus or minus. 1 over 1 is a 1. 1 over 2 is 1/2. 2 over 1 is a 2. 2 over 2 is a 1. I've already got that down. 4 over 1 is a 4. And 4 over 2 is a 2. So box that. Make sure you box something, or else I don't know which one you're telling me is right. Okay? Now, a lot of times Weber State will do the fractions. So I'm going to test 1/2. So I go 0.5 store, enter. Then I go 2 membar, enter, raise it to the 4th, minus membar, enter, raise it to the 3rd, plus 7 membar, enter, x squared, minus 4 membar, enter, minus 4, enter, and it did not work. Now I'm going to keep track right here. Okay, I'm going to do a negative 1/2. Negative 0.5, store, enter, up, enter, and it worked. The reason I started with the fractions is because Weber State usually has it the fractions. I wouldn't normally do that. I would try the 1, the 2, and the 4, and then I would resort to the 1/2. But I just knew what to do on this one. So 4, 3, 2, 1 constant. I'm not missing anything. Coefficients are 2, negative 1, 7, negative 4, negative 4. Okay, put a line underneath. Now, don't freak out on this. Multiplying by a negative 1/2 is the same thing as dividing by negative 2. So if you have a 2, bring that down. 2 divided by negative 2 is negative 1. Negative 1 and a negative 1 is a negative 2. Negative 2 divided by negative 2 is 1. 7 plus 1 is 8. 8 divided by negative 2 is negative 4. Negative 4 and negative 4 is a negative 8. Divide by negative 2, positive 4, done. Okay, now look at what I've got, 2288. If I take a 2 out of these guys, I turn it into 1, negative 1. If I take an 8 out of this guy, I turn it into 1, negative 1. I can tell right there that that guy's going to factor. So I don't need to keep going. So I've got a 4th, so this is now a 3rd. So I have a 2x to the 3rd minus 2x to the 2nd, a plus 8x minus 8 equals 0. I can also see that 2 goes into all these numbers. So I'm going to take out a 2, and I'm left with x to the 2nd minus x plus 8 divided by 2 is a 4x minus 8 divided by 2 is a 4, close it off, equals 0. Now that x to the 2nd, this should be a, sorry, I didn't take out an x, so this should be a 3, and that should be a squared. I'm used to being with you guys, so you guys can correct me. Okay, so an x to the 3rd goes to an x to the 2nd and an x to the 1st. And then the x to the 2nd is supposed to be a negative with it, so right there goes a negative 1. The x is supposed to be a plus 4, so that's a plus 4. Check that L is a positive 4 times a negative 1, give you a negative 4. Yes. So I have one rational 0 I've already proven of the negative 1/2 because I did the long division and I got a 0. If I set that equal to 0, I get x equals 1. That's another rational 0. These are going to give me other zeros. So I'm going to box that very clearly. I've demonstrated those are my rationals. And now I'm going to go x squared plus 4 equals 0. X squared equals negative 4. Square root it. X equals plus or minus 2i, like that. Okay? So I've got 1, 2, 3, 4, exponent of 4. I can plug these guys in, make sure I get a 0, and I've checked part of it. Okay? Okay, so this stuff right here, this last little piece, remember I have added problems to your homework today. The problems I've added, in addition to what's there, is page 387, questions 21 through 31 odd. The reason I did that is because for the first time since I've taught with Weaver, which has been a long time, this problem popped up on someone's midterm, and I'd never seen anything like it before. So I thought I probably better add it in just in case it gets into yours, okay? So you can start figuring out how many solutions you have, how many are positive, how many are negative, by analyzing the equation, basically, okay? So to find the number of positive solutions, you count the number of sign changes, and you'd count the number of sign changes in the original, okay? To find the number of possible negatives, you replace x with negative x and count the sign changes in the original problem, okay? So I'm going to go nice and slowly, and you know, I don't think you're going to see this, but I just want to be safe, okay? Okay, so here we go with example 5. We're almost done. Given this equation, find the number of possible positive, negative, and complex solutions, okay? And you have to make sure you have a constant in your equation, which we do, okay? So I'm going to go like this. I'm going to go positive. Positive is easy. All you do is put this in the right order. So we have exponent of 3, 2, 1, constant. Now you're going to count the number of sign changes. So this is a positive, and it goes to a negative, so the sign change is 1. Then you go from a negative to a positive, and there's another sign change. Then you go from a positive to a negative, and that gives you another sign change. So we have 3 sign changes, okay? So you're going to have 3 positive solutions. Then what you do is you subtract the number 2 from this 3. The reason you subtract 2 is because if you have complex, they come in pairs. So we have to subtract 2. So you're either going to have 3, or 3 subtract 2 is 1. So you're either going to have 3 or 1 positive solutions, okay? Now let's do the negative. The negative is a little bit more difficult. I'm going to show you a long way to do it, and then I'm going to show you a different way to do it, okay, an easier way. Okay, so take that equation. Everywhere you see an x, put in a negative x. So it's a negative x to the third minus 2 times a negative x to the second plus 4 times a negative x minus 1 equals 0. Now simplify that. A negative to the third is a negative x to the third. A negative to the second is a positive, but you have that negative right there. So it's a negative 2 x to the second. 4 times negative x is negative 4x minus 1 equals 0. Count your sign changes, okay? Here there's none, here there's none, here there's none. So there are no sign changes. So you're going to have no negative solutions because there was no sign change, okay? Oops, I switched those. Negative. No negative solutions because there was no sign change. Now let me show you a quick trick. If the exponent is odd, see here on those 2 things right there, how the exponents were 3 and 1, so they were odd. If the exponent's odd, the sign that was there originally will change when you put in a negative x. So see that x to the third was a positive, and then it was a negative. This guy's not odd, so he stays the same. This guy's odd, he changes, and the constant just stays the same. So if you want to do it that way, you can totally do it that way, whatever makes sense, okay? You guys, I know I'm going to have 3 solutions, okay? So here are my options. Option 1, I have 3 positive solutions. No negative, okay? Never any negative. The other option is 1. So I could have 1 positive solution. Hi. Okay, that's great. I could have one positive solution, but what about, sorry, it's okay, you're not doing anything wrong. I just want you to know I'm totally okay. I'm just recording a lesson. It's okay, you're totally good. I could have one positive solution. So what about the other two solutions? Well, they would have to be complex. So I would have two complex solutions. The reason, first of all, what does complex mean? Complex means you have a square root in there, or you have an I in there, or you have both in there. So that's it. That's your answer. Okay? Okay, let's do one more and then we're done. Question 3, given this equation, find the possible number of positive, negative, and complex. Okay? So here we go. So here is positive. Okay, so count the number of sign changes. No sign change here, goes from positive to positive. I have a sign change here. From negative to positive, that's a sign change. And I'm going to put plus 0. Oh, no. I'm not going to put plus 0. I got to start over. I'm going to take out an x. So if I take out an x, then I'm left with 4x to the 5th plus 5x to the 3rd minus 5x to the 2nd plus 2 equals 0. Now I'm going to analyze the sign changes of the inside. Okay, so here, no change. Here is a negative, from positive to negative, and here's a sign change. So we have two sign changes. So you could have two positive solutions, or you could have 0 positive solutions, because 2 minus 2 is 0. Okay, now let's do negative. So look at that right there, okay, the original problem. Write it down exactly the way it is. If it has an odd exponent, change the sign when you write it down. So the x to the 6th, that's a positive exponent, so I'm going to, or an even exponent, so I'm going to write it down. The 4 is an even exponent, so I'm not going to change it. The 3 is an odd exponent, so I'm going to change it to a positive 5x to the 3rd. The 1 is an odd exponent, so I'm going to change the sign like that. Okay, that's the same thing as doing this. 4 times a negative x to the 6th plus 5 times a negative x to the 4th minus 5 times a negative x to the 3rd plus 2 times a negative x equals 0. That's what you're going to end up with. Okay, you should probably write both those lines. We just wouldn't want we were to take points off. Count the number of sign changes. I have 1. And so you're going to have 1 negative solution for sure. The next number would be -1, and there's no such thing as -1 solutions. Okay, so, oh, by the way, sorry, go back to that. If I took out an x right there, so I had a constant, then I'd have a 4x to the 5th, a plus 5x to the 3rd, a plus 5x to the 2nd, and a minus 2. So I would still just have the 1 sign change. Okay, so here are your options. I know I'm going to have 6 solutions. So you could have 2 positive, 1 negative. How many would that be left? That would be 3 complex. Okay, now just because they are complex, the imaginaries have to come in pairs, but it's possible that you could have one root that has a square root in it that doesn't come in a pair. So an odd number of complex is fine. Okay, another option, you know you're going to have 1 negative. Okay, so you could have 0 positive, you could have 1 negative, and that would leave you with 5 complex. The other option is, that's it. So 2 positives, you know you're going to have a negative. So this one fills in 3, this one fills in 5. Altogether here you have 6, altogether there you have 6, and that's your answer. Okay, so those problems that I added to this assignment, page 387, 21 through 31 odd, have to do with these last problems that I just did. Okay, so before you come to class next time, make sure you have that assignment done. Okay, that's it.